Today's lesson is on angles in a triangle. So first of all, I'll show you this Geogebra file. We can see that in a triangle, so this is a special type of triangle, it's an equilateral triangle where all the angles are the same. And we can see that from here, see the blue matches up with what the blue angle is, red matches up with red, and green matches up with green, and we can see that they add to 180 degrees. Now let's think what happens when I change one of these points, or the angles change. Like you can see blue's got bigger and so on and so on, but they still always add to 180 degrees. So let's see if that's always true. Yep, still 180, still 180. Wherever I move it, as long as this is a triangle, the angles are going to add to 180 degrees, and we can see them moving around. So in your books, can you get down angles in a triangle always add to 180 degrees? Or you could just put, as it says up, I can't mark it on, but it says triangle sum to 180 degrees, same as saying add. Right, so next up, the types of triangles that we might see. This is a right angled triangle. So get that down in your book and get an example of what it looks like. We can tell that because there'll be a little square drawn denoting that that's 90 degrees. And then the other two angles could be anything. This is an isosceles triangle. And what's special about that is that it's got two sides the same. But more importantly for us, because we're looking at angles, two angles that are the same at the base of the triangle. But this, it could be drawn another way, so it might not look like the base, but I could draw it this way, and these angles would still be the same. So it's like either side of the two sides are the same, and then this one would be different to the others. Otherwise, if it was the same, it would be an equilateral triangle. Lateral triangle, and just I haven't really said, but these marks mean that the side lengths are the same, and these mark means the angles are the same. So just like on the isosceles triangle, when we marked here and here, those marks mean that they are the same. Don't get it confused with an arrow, which denotes that lines are parallel. But don't worry about this for this lesson. Equilateral, all sides and angles are the same. So because all the angles are the same, then it's got to be 180 divided by 3 because there's 3 angles, so all angles are 60 degrees. We saw that in the Geogebra file at the start. And then this is an example of a scalene triangle where all the angles and all the sides are different lengths and different sizes. So all angles and sides are different. And you could get a right angled triangle that is also an isosceles triangle, because this could be 45 degrees and this could be 45 degrees. And you could also get a right angled triangle, so in that case these sides would be the same. And you could also get a right angled triangle that's a scalene, because say this was 30. Well, I know they need to add to 180, so 90 add 30 is 120, so this must be 60 degrees. So we can see that it's a scalene right angled triangle, and this is an isosceles right angled triangle as well. So they're the different types of triangles that you might come across. Isosceles triangles are used lots because they're, if you know one angle, you can work out the other two. So they're used lots in GCSE questions. Right, let's have a look at some questions then. can you have a go at each of these questions? I'll just make them bigger for a second. You can pause the video on them, have a go at them. Again, pause it, have a go at those two. Pause it, have a go at it. And pause it and have a go at it. And then I'll go through them all now. So you should have had a go at all of these by now. So get your red pen out, ready to mark. What is the sum of the interior angles of a triangle? We know that it's... Oh, I don't want to draw a highlighter. We know that it is 180. Don't forget your degree sign. How many angles do you need to know to be able to find all the interior angles of a triangle? Well, it depends what the triangle is really, because if it's a scalene, then if I knew one, say it was 60 degrees, then I can't say what the other two are, because I know they must add. So both of these, let's colour them in, would add to 120 degrees. Where have I got that from? Well, I know that 60 had 120 is 180, but I couldn't say for definite what they are. So if it was a scalene, that looks a bit like a right angle. Let's try and make it a bit different. If it was a scalene, then I'd need to know two angles. So I'd need to know that maybe that's 60 and that's 20, for example. And then I could say that that's 100. So I need to know at least two in a scalene. If it's isosceles, then if I know that one, I can work out both of these, because I know that it's going to be whatever the top one is, 180, take away that top one, divide by 2. So if it's isosceles, I only need to know one. If it's equilateral, then I know that all the angles are 60. So it depends on what triangle it is. If it's scalene, I need to know 2. Isosceles, then I need 1. If it's a right angle, then I need 2 of them. But yeah, it just depends on the triangle. If one angle in an isosceles triangle is 60 degrees, is this an equilateral triangle? Well, let's see. An example of an isosceles where the angle might be 60 degrees is where the top one is 60 degrees. Well, what would these ones have to be then? Because I know they've got to be the same. So 180 take away 60 is 120. Because these bottom ones are the same, 120 over 2 is 60 degrees. So therefore these are 60 degrees as well. So it would be an equilateral triangle. Let's see the other situation where an isosceles, so let's say it's this angle here is 60 degrees. Well, I know these base angles are the same, so they add to 120, so that means this must be 60 as well. So if one angle in isosceles is 60, then yes, it has to be an equilateral as well. Can a triangle have two right angles? Well, let's try and draw one. So if I have something like that, then I would really like to draw along like that, but I know that's not a right angle, so I can't draw a line like that. So the other line, the third line, would go up, and these two would be parallel and never meet. So that's an example where it couldn't happen. Or maybe I could have my right angle here, and I'd like it to come down from the top down to the bottom there, but if I have a 90-degree angle, then I know it's got to go like that, and these lines would be parallel. So let's look at it in terms of the numbers. Well, if two of the angles are 90 degrees, then that already makes 180. So that leaves the last angle to be 0 degrees, which isn't possible in our triangle. It needs to have some sort of degree. And a triangle, by definition, has 3 angles. So you can't have a 90, 90 and a 0, because 0 is not an angle. So there you go. They're your first questions. Next one. So let's call this question 1 and this question 2. So I know they all add to 180. So if I do 180, take away 72, take away 51, then, and I'm doing this in my calculator just because it's nice and easy. You could do it without to challenge yourself. It's 57 degrees. Another way you could have done it is 51 add 72. which is 123. Do 180, take away 123, and you still get the same answer of 57 degrees. Right, now this one, remember these lines are really important because they show us that it's an isosceles. That means that these two angles as well are the same. So it's going to be that either side of the line is where my angles are the same. It's not at the top where the two same lines meet. That one's different, this one's different to these two down here, but these two that I've just marked on are the same. So I know they all add to 180. So if I do 180 take away 43, then that gets me 137. So then these base angles are the same. So I know that I can divide it by 2 and I'll get 68.5 degrees. And you can have decimal degrees, so don't be put off by that. Right, next question. So if you haven't already, make sure you have a go at it. So it says two shapes are connected at the edge in the diagram below. Calculate the size of the obtuse angle VWX. So VWX, remember that letter in the middle is where the angle's created. So that's the one I'm trying to find. So that's good that I know what that is. It's obtuse because it's bigger than 90 but smaller than 180. And notice that all of these lines mean that this shape is a square. X, W, Z, Y is a square. And the other really important thing to notice is that one of these lines is also here, which means that VWZ is an isosceles triangle. So that means that this angle is the same as that angle, meaning that it's 35 degrees. So if both of those are 35 degrees, then it must be 180 take away 35, take away 35, or equally you could do it on 180 take away 70, which is 110 degrees. So VWX equals 110 degrees. Does that make sense? Is it obtuse? Yeah, it is. So that fits in with what they've asked me in the question. Right, next up. One angle in an isosceles is 30. Actually, I'm going to give myself a bit more space for this one. One angle in an isosceles triangle is 30 degrees. What are the other two angles? Give two possible solutions. Okay, so they haven't given us a diagram here, so let's draw one ourselves. Doesn't have to be perfect, doesn't even have to be with a ruler, as mine isn't. Actually, I'm just going to draw it a bit bigger to give myself more space. So I know an isosceles triangle will look something like that. It could be rotated in any way, but let's just draw it as I know it best. One angle is 30 degrees, so let's say that this top angle is 30 degrees. Then I know that the bottom ones are the same, so I can do 180 take away 30, which is 150. 150 divided by 2, which is 75 degrees. So that means that the other two here are 75 degrees. Now notice it says give two possible solutions. That's because my 30, my angle that I'm given, could not be that top angle. I could be trying to find that angle. So I could say that this is 30 degrees. Then I know that this must be 30 degrees because remember those base angles are the same. So 180 take away 30 take away 30 equals 120. So that means that top angle is 120 degrees. Notice my triangles aren't drawn to scale. They're not accurate because this one looks exactly the same as this one, but I've just written on that the angles are different, which is fine to do. It doesn't have to look exact or doesn't have to even look like what it's going to look like, just so you've got an idea of this is an isosceles. So there are your two possible solutions. Right, next up, I would like you to have a go at the highlighted questions in yellow here. So make sure you show you're working. Make it clear what you're doing at each stage. Might help you to just draw it out quickly in your book, or even try and print this sheet out if you can. Just take a screenshot of it and then print it out. But you can just draw it really quickly as well. So have a go at them, pause the video. Should take you, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 questions. So yeah, maybe like 20 minutes. And then here are the answers. Okay, so pause the video, make sure you've had a chance to mark those in red, and then if you're like, I really don't understand how you've got those answers, then just email me. Right, have a great rest of your day.